Foundations of amateur radio. One of the often repeated attributes of noise in antennas is that man-made noise is vertically polarized, and that is why a vertical antenna sounds noisier than a horizontal dipole. It's an interesting thing to say, but is it true? Let's start with what constitutes man-made noise. Cars driving past, solar panel inverters, pool pumps, high-tension power lines, garage door openers, broadband internet modems, LED lights, lawn mowers, leaf blowers, plasma televisions, and so on. The more you think about this, the more noisemakers you discover. So, are these noise sources all aligned in the same way, making the same noise? Clearly not. There is no alignment standard for installing a lamp, how to align your lawnmower, which direction to drive, what angle to point your garage door opener. So the statement that man-made noise is vertical is clearly bogus. That doesn't mean that the rest of the statement is also wrong. A vertical antenna in an urban environment often sounds much noisier than a horizontal one, sometimes by several dB. So what's going on? One suggestion is that the difference lies in the antenna itself. What if both noise sources, horizontal and vertically polarized, were the same, but the antenna heard them differently? How would that look? For starters, a horizontal dipole has a higher sensitivity at a higher angle than a vertical antenna does. So anything arriving at a low angle is picked up by the vertical but not by the horizontal dipole. The noise that we're talking about is local. We'll get to why in just a moment. Being local, it gets to the antenna via ground wave propagation rather than via the ionosphere. I claimed that the man-made noise we're discussing is local. It's not all local, but if it's remote, it's coming via the ionosphere, and we know that it arrives at whatever angle it pleases, so there is little or no difference between a vertical and a horizontal dipole from a noise perspective for signals arriving via the ionosphere. There is another effect, attenuation or signal loss. In this case, the loss of strength, specifically noise strength. More attenuation is the same as more signal loss. Combining ground wave propagation and attenuation brings us to another difference between a horizontal and a vertically polarized noise source. A horizontally polarized ground wave experiences more attenuation than a vertical one. This means that noise that is local travels further and is louder when it's vertical, compared to when it's horizontal. Sometimes the difference is over 20 dB. I've been talking about horizontal and vertically polarized noise. But what if the noise is coming at an angle, like the random noisemakers around you? A simple way to think of it is that every angle has a horizontal and a vertical part, in much the same way as a right-angled triangle has three sides, one horizontal, one vertical, and one on an angle. Putting this all together, we have a number of different effects, all conspiring to make the vertically polarized part of noise travel further, be louder, and received better by a vertical antenna, compared to the horizontally polarized part, which doesn't travel as far, is softer and heard less by a horizontal dipole. One more thing, the isolation between vertical and horizontal polarization can be as much as 40 dB, so a horizontal dipole won't hear vertically polarized signals well, if at all, and vice versa. That doesn't make the vertical antenna useless, far from it. It's great for transmitting a long-distance signal. It's small, simple to set up, and if you're in a quiet area away from noisemakers, around 500 meters to a kilometer or so, it's just fine as an antenna. It also doesn't need to be erected half a wavelength above the ground, doesn't need any skyhooks, is omnidirectional, and in common use for most local mobile communications. So don't write off the vertical just because it sounds noisier. All antennas are a compromise between various elements. I've said it before and I'll say it again, likely plenty more times beyond that. The perfect antenna does not exist. We can prove that. So whatever you pick, whatever you think is the most important, that's what you'll start with, and select various aspects as you go. A vertical antenna is no worse than a horizontal dipole. It's different, just like a Yagi is different, or a disc cone, or any one of the infinite supplies of antenna options. Knowing what the parameters are is the first step. Oh, and if your neighbors complain about your lawn, tell them it's because of your noise floor. I'm Ono, Victor Kilo 6 Foxtrot Lima Alpha Bravo.